Hello viewers, welcome to another video by Meston Educational Services. In this particular video, I am going to demonstrate how you could use the Python module on the TI Nspire CAS handheld and also on the TI Nspire teacher and student software. So Python was actually added on the TI Nspire CX-II with version 5.2 and 5.3. So 5.3 is the most current version of the software for the handheld and for the student or teacher software. Now you will see under applications, the very last application is actually add Python, and when you want to write a program or your first code, you will go and use the new option, and then you will be asked to give a name to your program. But you could also use the shell option to do a 2 or 3 line code. If you just want to test something quickly, you could use the shell page. So I am going to use the add Python module, and I'm going to add a new program, and I'm just going to call it program 1. So here I've called it program 1. Now before I can go any further, if you're using the computer software, it is always recommended that we are on the handheld view, not the computer view, because your programs will not run on the computer view. So a shortcut to go to the handheld view is Alt Shift and the letter H. Of course, you can toggle between the handheld view and the computer view. At times writing the code in the computer view is faster, but to run the program, you should be in the handheld view. To run the program, I'll simply do Control R, and it's easy to remember that shortcut R for run. And if I want to save the program, I'll just do Control B. Now, when you run the program, it will not run on the editor page. It will actually run on a new page, which is called the Python shell page. Now, you can delete the Python shell page if you want, but I suggest just to leave it there. Instead, use the clear history option, because when you keep running a program, it will just keep adding to the shell page. So you can clear the history, but to clear the history, you can't use the delete option. You have to actually use the menu and do clear history, or you can use the TI system import module at the beginning, and then every time you run a program, you just say please clear the history. That's another way of doing it. Now when you run a program, the first line you will see would be the name of the program with the extension .py. The second line would be the name of the program with the import, and after that, anything that you want to displayed would you would probably use the print command, and it will display the result. So that would always be what your shell page would look like. Now TI Nspire has the CX-II has these as built-in modules. So you've got the maths module for Python, the random module, the TI plot library, that's for graphing and anything else, the TI hub and the rover. These are external connections to your handheld, and likewise you have additional modules. So I'll talk about the hub and the rover and the additional modules separately when I actually get to those slides. So the additional modules that you have are the complex maths module, the time, the TI system. As I said, I tend to use that frequently. Then you have the TI draw and the TI image, whereby you'll be dealing with images. Okay, so there are these built-in commands, and it's better to use the built-in commands using the menu, because whether it's a function or any of the controls or operators, they actually need some proper tabs or spacing, and of course at the end of the line, or in the loop, wherever you are using that, there needs to be a colon, and if you miss the colon, it would give you an error. So if you use the built-ins, it will automatically put the colon for you and just do the right thing for you. So I highly recommend using actually the menu to do any of these, or to use any of the functions or controls. If you want to clear the history on the shell page, now this is a view of the shell page. Under tools, you see option 4, which is clear history. Likewise, if you want to rerun the program, you just do Control R. So you don't need to go back to the editor page. You could just rerun a program on the shell page. So you've got the indent, the shortcut is tab, and dedent is the shortcut is shift and tab. So when you tab, actually it moves the cursor by 2 spaces to the right, and if you do shift and tab, it will move the cursor to the left by 2 spaces. And when you use any of the built-ins, you would be obviously asked to indent or dedent, so that's something that you need to be wary of. Likewise, if I want to add a comment to my code, if I just do Control T, it will put the hash symbol, and then I can put that comment. Now the comment line will not be a part of the code as long as the hash is there in front of it. There are certain shortcuts that are very helpful. If you want to go to the beginning of the line, wherever your cursor is, just to Control 8, it will go to the beginning of that line. Likewise, to the end of the line, just to Control 2. And then to go to the top of the program, Control 7, and to jump to the bottom, just to Control 1. So these are very handy shortcuts. All right, so under actions, you have got a new program that you could create. You could open an existing program. You can create a copy, and I tend to create copies when I'm doing, very similar programs. So I'll just copy them and then make minor edits to my existing program. You could rename a current program if you decide that the name is not probably appropriate. You can change the name. You can access the settings for the programs if you have to. That's also under actions. Now, these are the built-ins through menu. So the first one is the functions, and we've got if you want to define a function and the function return. So these are kind of user defined functions that you will create. Then under controls, you have got the if condition, then you've got the for loop, and you'll see the for loop, you can actually run it in 4 different ways. Then you've got the while loop, and of course then the conclusion or the else if and else loop commands are there as well. Then on the extreme right, you see the operators, and the thing that I need to mention over here, if you are in an equation, the left hand side and the right hand side, you're equating, you actually have to use the double equality sign. So equal to twice. If you just use the equal to sign once, you are actually storing it as a variable. And when I write a program, I'll talk about it again. Then we go on to the lists, and with a list you can create an empty list, or if you have an existing list, you can measure the length of it. You can determine the minimum or maximum value. You can add by using the append option to your list, so you can add or remove elements, and likewise you can find the sum of the list and whole lot of things. So list is something that we use very often in Python. Then the type, which is in the middle, the user could input integer, or for my calculation I could be using an integer calculation, so I need to specify if it's an integer. Otherwise, any numeric value would be a float. I could round off a number to certain number of decimal places. If it is a string, I need to use the string command and put it within quotation marks. And likewise with complex numbers, I can input from there. And one reminder over here, the complex number actually doesn't use the letter I for imaginary number, but it uses the letter J in Python. And then on the very right, you've got the input and output, and the equivalent of display in TI Basic is print in Python. So when you print, it actually is going to display the output on the screen. The second one is a user input, and then of course I'll talk about the evaluate function in certain other programs. And then when you're printing something, especially if you want to print to certain number of decimal places, or you want it displayed in a different way, then you can use the dot format command, which is also built into Python. So the first of the modules is the maths module, and you can see over there that I've got the constants, Euler's number and pi. Then the next one is all trig ratios, and of course you can even change angles from degrees to radians and so on. Then you've got other standard maths calculations, square root, power, log, and a whole lot of other things. And once we start using we write programs using the maths module, then I'll be talking more of these there. The next bit is the random module. The random module is something that I use very often. At times I want to generate a random number, or if you're writing a code whereby you're looking at getting a head or a tail or rolling a dice, what's the output, you'll use the random module. But I also use it to use random colors, especially in the TI draw module. The hub and the rover, as I said, are external connections to the computer or to the handheld, and whether it's the hub or the rover, there need to be specific commands, and that's why we have a hub and rover module having their own Python commands, because the moment I connect the hub, there may be certain inputs or outputs, so I need to tell the program on which port is the input or the output, and what is the output, whether it is a sound device or whether it is a temperature sensor. All that needs to be specified. And to use the rover, I have to still use the hub, because all the code actually is sent to the rover, and then the commands are executed, and then the rover would move as per the commands that we have sent to it through the hub. So the additional modules are the complex maths module, the time, the TI system module is something very handy. And when I say it's handy, you can talk to other applications. So you may have defined a variable on the notes page, or you may have defined a variable on any other application using your CAS, and you want to use that variable in Python. You could actually use a recall option, and likewise you could do the opposite. You can store a variable in Python and send it to the calculator page, and the variable could even be form of list. So you'll see I could actually do a graph on the TI Nspire graphs page, or use the data and statistics page by using the output generated by Python over here. So what I'm saying is you can actually get Python to talk to all other applications on your handheld using the TI system import module. Then TI draw is something that a lot of beginners in Python enjoy, because you can do random shapes, you can do colors and a whole lot of things, and that's a good way to start. And you can obviously bring in images into your handheld and deal with images using Python. So the TI system module obviously gives you the opportunity to call any of the variables from any application. So you'll use the recall option, and likewise if you want to store something and use them in other applications, then you'll use the store value or the store list option. Then moving further, the TI draw module, you could do a whole lot of shapes, and you could color the shapes, and you could put text over there, and you'll just enjoy using this particular module. And I've done a few videos and will be doing more videos whereby I use the TI draw module. So what are the key features of the Python editor? The thing is, especially when you are using auto indenting or using the built-ins, it uses colors like blue and red, so it tells you what basically they are. So if there are any operators, it will always go in red. Then the other thing is, if you're using the built-ins, it will put the colon and everything automatically. So there's auto indenting, and it's pretty much menu driven. So I highly recommend using the menu rather than trying to type in commands like if or for, because then you may miss out either on the colon or you may have incorrect indenting. So highly recommend that you use the features that are available both on the software and on the handheld. And as I mentioned, you can actually talk to other applications using Python. There is version 5.3, and the only new addition on 5.3 is you can use the BBC microbit, which is a multifunctional microcontroller on board, which essentially initially was basically just displays, but now it's got a whole lot of other things, like you can play sound and music with the speakers. You can connect two handhelds, both need to have the BBC microbit board. You could read output values from connected sensors. You could connect sensors to the TI Innovator Hub, and you could actually display outputs over there. And of course, you can do a lot more. And then finally, option 7 under actions is install as Python module. So if I've written a program and I want to use this program in another program, if I use the install as Python module, current program that I've created, then I could put it into another program, and it will be called as, whatever the name I have, it would do that import. So it's pretty handy if you want to make your code short and you have got 6 or 7 programs that you want to use. That's a good way to go. Okay, let's go and write our first program. I'm going to use write a very simple program. So we're going to test whether the number is prime or not. And for us to run this program, the very first thing is there has to be a number that we have to ask the user to input. So we're going to use the maths module. So from maths import, so when you click on maths, it will do that. And the first thing is I need to store the number that the user is inputting. So I've just called the stored number as number, but I could have just used the letters NUM, but I just decided to use the word number because it's an integer. So I've got that int in front and input from the user. So when actually this line of the code runs, it will display enter any number for the user. And you can add anything else to the line. You could say a number greater than 1, and that would be displayed for the user. So once the user enters the number, now the highlighted line is actually a comment that I have put over there because it's got the hash, so it's not a part of the code. So the next line, it says if the number is greater than 1. So there are two things I want you to notice. If is in blue color, that happens automatically. And there's the greater than sign, which is a comparison operator, that's in red. And after 1, there is a colon. Now all these will happen directly or properly if you use the menu rather than trying to type them in. But if you are an accomplished Python programmer, then of course you could just type this in. So that's my if command, and the if command needs to end with an else command, and you'll see that later on. Then I've got another command, and because I've used the if command and it is one of the controls, you'll see it creates a tab. So you've got 2 spaces for my next line for, and that will automatically happen if you use the menu. And the same thing is going to happen for the for and the if command, because they are controls I'm using. They will actually have some indent each time I do them. So let's look at the for. So the first line is if the number is greater than 1, I want to run a loop. So the first prime number I'm going to check is the number divisible by 2. So that's my test that I'm going to run. Is it divisible by 3, and so on. And my stopping number in the range would be the number that the user has input. So if the user input number 9, so I'm going to go from 2, 3, 4, 5, 6, 7, 8, 9. But I may not need to go to 9 all the way. And I'll tell you, there is a break in the loop when a certain condition is met. Now I have used the letter I for iteration. So for I in the range, starting with 2 and going up to the number, you could use any letter instead of I. Now the third line where I'm saying if the number when divided by I. Now when, of course, it is a division, but the percentage sign, actually the result is the remainder. So it says if the remainder is equal to 0, that's what actually the code is, then that means the number is divisible by whatever the iteration value is in this. So when the loop is running, it starts with 2, then goes to 3. So let's say I'm in the second loop, it's going to divide my number by 3. And if I get a remainder equal to 0, it tells me that the number is not prime. And if it is not, if my remainder is not 0, then it will go to the next loop and it will keep running until it has done all the tests. However, if it comes, the moment it comes across the first number where I get the remainder is 0, it will tell me that the number is not prime. And you can see that's under else I've said print that the number is a prime number, but otherwise we are saying it is not a prime number. And I'll just go back over here and explain the code again. So we are dividing and looking at what the remainder is, and we are checking the remainder each time. And if the remainder is 0, we are saying the number is not a prime number. And if the remainder is not 0, it is going through each of the loops, and the moment it detects that with some number I get a remainder of 0, it will say break the loop, end the loop, because we have found a number where this number is divisible by a certain number. So let's say if my number was 121 is divisible by 11. So when it's running the loop, when it gets to number 11, it will give me the remainder as 0, and it will break the loop over there because it's found the first number that divides 121. So the else command. Now if the condition is not met, then of course what we are going to say, the number is a prime number, and if it is not a prime number, then obviously we need to see what number is dividing it. And my fourth line on this screen where you see print I comma is the first factor. It's going to tell you which is the first number that divides my given number by whatever the iteration number is. So that's a simple command. So let's say you have written the whole code, and if you do Control R, it will ask the user to input a number. So in my case, the user input the number 193, and we know 193 is a prime number, so it displays the result 193 is a prime number. And as I mentioned, if I put 121, my number is 121. Now it says 121 is not a prime number, and it tells me 11 is the first factor. And there could be other factors, for a certain number as well, but it will just give you the first factor. So that's a test for you to do the prime number. I'm going to look at another program whereby we'll draw random polygons, and I'm going to use the for loop in the program, and also I'm going to use the random module. So because I'm using the draw module, so I use the TI draw module import and then the random module import. So all you need to do is just click and it will import it for you. So to start with, I've created an x coordinate and a y coordinate because I'm going point by point. So it will join my first point to the second point to the third point, and at the moment I have an empty list for the x coordinate and the y coordinate. Now I've got the for loop. It says for I. Now as I said, I could use any letter. I don't have to use I in the range. And when I put 7, that means it's going to give me a 7-sided polygon. So that number for a polygon needs to be 3 or more because it's a closed shape. Now when I'm running this, I'm saying generate a random integer between 10 and 250, and the reason I've taken 10 and 250 is to just fit my shape on the screen. So that's in pixels there, and likewise y can take any values between 10 and 200. So those are integer values. And when I run this loop, the first time it goes when I is 0 or when I is 1 and then I is 2, it's going to create an x coordinate for me and a corresponding y coordinate. So it's going to create a point each time, and we know that for a point I need the x value and the y value. So you will see I've got over here x coordinate dot append. So when it runs the loop, it's going to actually just add that value each time. So I'm storing that value as x, and then I'm for the x coordinate, and I'm storing it as y, and each time it's appending it to the loop. So append means it's populating the empty list that I started with. So once I've got all these points, I'll have the same number of x and y points. So the length of the x list and the length of the y list would be the same. I don't want to print those lists out because if I've got 100 points for x and 100 points for y, it's going to be a lot of information on the screen. So I don't need to print it out, but it's actually stored in the list called x coordinate and y coordinate. Now if I don't set a color by default, it will draw the polygon or fill the polygon with black color, but if I assign a color, it will do that. So I've got a set color command. So set color red, green and blue. So for red, I've said it could be any random integer between 0 and 255. Likewise for green, a random integer between 0 and 255, and same with blue. So it runs this command and it generates a certain combination for red, green and blue. And in this particular case, if I'm just filling the polygon, then I don't need the draw polygon command. But if I'm using the draw polygon command by itself, the outline would be the color that I have selected. And of course, set color with fill polygon will fill it up. So once I run the program, if I do Control R, it does that. Now I've got actually 5 different outputs because I've run the program 5 times and I've just done a screen capture. But the very first one you see was with n equal to 7, so 7-sided polygon. The second one is a triangle, and that means for me n would have been 3, and you can have any number of sides, 30, 40, 50, and you get these interesting shapes. So that's really using the draw module. So I'll end this video presentation over here, and soon I'll be uploading more videos where I'll use different modules. So please subscribe to my channel if you want to pick up the other modules and how you could use them for coding. So thank you for watching.